Hi guys, today we are going to continue our equation on solving radical equations. In the earlier video we looked at the case where we only had one radical expression. For this video we're going to look at the case where we have more than one radical expression. To be more specific, we're going to look at the case where we have two. Let's go ahead, open it up with problem A, and BP, that is my made up abbreviation for bonus problems. Bonus problems, we usually do them if we have time, but we're online now, so we definitely have time. Well, we're on YouTube, yeah. Okay, so let's do this. So the question is, how are we gonna handle it? If we only have one radical, then our primary goal is to isolate that one radical that we see. But if we have more than one radical, namely two, then we need to fix it so we have a radical on each side. So my dilemma right now is which of these two radicals should I move? It doesn't really matter. The reason why I'm going to move the second though is just so everything could be positive. Okay, so if you choose to add the square root of x to both sides, then that will leave us with square root of 3x minus 2 equals to whatever you see on the right. So one of the questions that I get is this: should I put 2 plus the square root of x or the square root of x plus 2? It doesn't matter. For me, I recommend that you put the radical part at the end, so that way you don't risk when you put the plus 2 thereafter, you don't overextend the radical by mistake and think that you're square rooting the entire x plus 2 versus just the x. So for aesthetic reasons, I put the radical part at the end. So we have 2 plus the square root of x. Fantastic. So now what are we gonna do? So now that we fixed it so we have one radical on each side, at this point we're gonna go ahead use the power rule to undo at least one of the radicals. So in this case, because the index is 2, to undo the square root, we're gonna go ahead square both sides. So at this point one of the radicals should be gone, but unfortunately it's not gonna get rid of both radicals. So on the left side, the square and the square root undo each other, and that will leave us with the radicand of 3x minus 2 equals whatever your heart desires on the right side. So on the right side, it's really up to you how you want to square it. If you remember the multiplication shortcut, or square of a plus b, where you have square of a binomial, you can go straight to answer a squared plus 2ab plus b squared. But I have no time for that multiplication shortcut, so with your permission, we're just gonna old school it. Let's go ahead, FOIL it out. So let's rewrite it without the exponent of 2, and that will leave us with 2 plus the square root of x times 2 plus the square root of x. Let's take our time and then clean it up, and then we'll see what we do thereafter. Product of the first terms will give us 4. Product of the outer terms will give us 2 square root of x. Product of the inner terms will give us another 2 square root of x. And product of the last terms, when you multiply the radicands, that should give us a square root of x squared. Or again, you can just say gives us x. It just depends how comfortable you are with the radicals, that you can probably skip a couple of steps. I'm just going to assume that we're a little rusty, and then we're going to be good to go. So let's go ahead, begin to simplify what we can. So we have 4 plus the sum of the middle terms, because the middle terms both have the same square root of x. They are like radicals. When we combine the numbers before the radicals, namely 2 and 2, that will give us 4 square root of x. So 4 square root of x plus the third term, or that fourth term, the square root of x squared simplifies to x, because we're either cool like that, or we can just say same speech, the square and the square root. I crossed it in different ways. So again, the square root of x squared simplifies to x, because we're either cool like that, or 2, we can just say that the square and the square root undo each other. So that's about it in terms of simplifying the right side. There's nothing else to combine. Let's go ahead, safely bring down the left. So now the question is, what kind of equation do we have now? So as you can see, we still have a leftover radical, so we still have a radical equation. But now what I'm going to ask myself is this: how many radicals do I have left? So in this case, where you only have one radical left, let's take our time and isolate that one radical that we have left. Let's go ahead, move the x, and go ahead, move that 4. So let's do this. So if we choose to subtract x from both sides and then subtract 4 from both sides, that will leave us with the following: 2x minus 6 is equal to 4 square root of x, and I believe that's it. Now this is where I'm at a crossroads. If I follow procedure, the procedure says this: if you have only one radical, then work your magic so you isolate the one radical. So technically we're supposed to work our magic and divide both sides by 4, but I'm gonna bite my tongue on that. Why? Because if we divide both sides by 4, I notice that 4 does not go into 2 and 6 a clean number of times, and that's going to give us fractions, which is just, if you want to struggle, go for it, but that's not my cup of tea. I think that's the saying in English. Cool. So what I want to get at is this. Our goal is to isolate the radical. If you can't, then just isolate it as much as possible. So multiplying it by a number, it's okay, but you don't want to add stuff to it. Okay, so now at this point we are going to apply the power rule to undo the leftover radical. Because the index is 2, then we're going to go ahead raise both sides to the second power. Okay, so on the left side, same speech. If you remember the multiplication shortcut, go for it. This will be like 4x squared minus 12 times 2, 24x plus 36, I think. Don't quote me on that. Let's go ahead, FOIL it out. Okay, so let's rewrite it without the exponent of 2. So that will give us 2x minus 6 times 2x minus 6 is equal to, on the right side, I would love to slash these two things, the square and the square root, but if I do that, I'm afraid that I will forget to square the 4, so I'm going to have to do that mentally. The square of 4, or 4 squared, is 16, and then when we square the radical, the square and the square root undo each other, and that will leave us with x. Fantastic. So let's go ahead, finish it off. So on the left side, if we choose to FOIL it out, that will give us 4x squared minus 12x minus another 12x followed by 36. Fantastic. So we had a radical equation with two radicals to one with one radical, and now we have a degree 2 equation or quadratic equation. How should we solve it? With your permission, we're going to solve by factoring, because I love factoring unless the numbers don't come to me. So let's go ahead, continue to simplify the left. When we combine the middle terms, that will give us negative 24x. We bring down the rest of the problem. So again, we're going to assume that it's factorable until we realize that it's not. Let's go ahead, set this equal to 0. To solve an equation by factoring, our first goal is to set the equation equal to 0. Then we factor, and then we follow procedure. So that will leave us with 4x squared, 30 or 40, how normal people speak, minus 40x plus 36 is equal to 0. So let's do this. The first thing that we're supposed to do when it comes to factoring is to watch out for common factors. 4x squared, 40x, and 36, I believe they have a common factor of 4. Let's go ahead, factor it out so we can tone down the numbers. So that will leave us with x squared minus 10x plus 9. Oh yeah, those are much nicer numbers. So now the question of the hour is this factorable? I hope so. So let me go ahead and do the corresponding x game. Because the leading coefficient is 1, the corresponding x game, we need factors of c that add up to b. Again, if you don't need this, and I don't need this, but apparently I need it, so that's why I write it. So this is a trinomial of the form ax squared plus bx plus c. So the constant term is 9. So we want factors of 9 where that add up to negative 10. We keep our cool. I think it's 1 and 9 where they're both negative, but let's check it. Product is 9, sum is negative 10, so we got a winner. What is it saying? Winner, winner, chicken dinner? Yeah, I told you not to let me say those sayings anymore. All right. So product of the first term should give us x squared, and we're going to go ahead use variable times itself. Okay, to complete the binomial factors, we're going to use the sides in the x game, so namely negative 1 and negative 9. And if you don't trust me, FOIL it out and you should get the same thing. So again, we are solving by factoring. So when it comes to solving quadratic equations by factoring, our first goal is to set the equation equal to 0, factor completely, and then we apply the zero factor property. So again, zero factor property states that if a product equals 0, one of these bad boys has to equal 0. I'm supposed to say either the first or second or third factor equals 0, but 4 doesn't have a variable, so it wouldn't really make sense to say either 4 equals 0, because 4 doesn't, so we're just going to skip it. So either the next factor equals 0 or that third factor equals 0. If the first factor equals 0, that's going to give us a solution of 1, or I should say proposed solution of 1. If the next factor equals 0, that's going to give us a proposed solution of 9. So again, I know that we nailed the algebra. I don't think we made a mistake because you would have called me on it. But the question is, are they really solutions? What if one is an extraneous solution? So when it comes to radical equations, checking is not optional. We have to check our answers to eliminate the extraneous roots. So let's go ahead and check it. Should we check it by hand? You know what, we could, but let's go ahead and use our calculator. So I'm going to put CK for check. I'm going to put, sorry, I'm trying to move this. The first solution is 1. And we're going to go ahead use our calculator. Let me go ahead and write down the original equation. So we have square root of 3x minus 2 minus square root of x equals 2. And you can do this by hand, but you've done it by hand. You have done it by hand several times. So let's go ahead and use our calculator. So we are going to store the number 1 for the variable x. So let me go ahead and remind us where that button is. So we punch in the number 1, and we want to tell the calculator, please store this number for x. So we're going to hit the store button. Okay, so it's the STO arrow, which is to the left of 1. And then you see an arrow pops up on the screen, and we're going to store it as x, which I'm pretty sure you're familiar with that button is. And then we'll hit enter. Okay, so then we have told the calculator, okay, we're going to store 1 for the variable x. So then I want to know, what does the left side simplify to? Again, the numbers are pretty small, so we can easily do it by hand, but we have no time for that. So let's punch in the expression as is. So we have square root of 3x minus 2, get out of the radical, minus square root, so second square root, x. Cool. And then we'll go ahead put equals, and according to the calculator, the left side simplifies to 0, and the right side there's nothing to punch in. So the question is, does 0 equal 2? Of course not. 0 does not equal 2. So my natural reaction is, oh man, I made a mistake. But no, we need to trust ourselves. We know we nailed it, which is just an extraneous solution. So again, extraneous solution is a solution of one of the new equations, but not of the original equation. On the quiz or test, I'm not expecting for you to write extraneous solution. I like to write it in our notes to remind me why is it that I ignored it. So just because one didn't check out, just because the number 1 didn't check out, it doesn't mean that 9 does have to or doesn't have to. So let's check both. Are we going to do it by hand? Of course not. We're going to take the green light that take advantage of the fact that we're given the green light to use our calculator. So same speech, we're going to store now 9 for x. So we're going to do 9. That's not 9. 9, hit the store button, and again, pause and rewind as many times as needed. We'll hit enter, and then we're gonna punch in the left. So we have square root, second square root, 3x minus 2, get out of the radical, so we use our side arrow, minus square root of x, second square root, and then the left side gives us 2. Equal sign, there's nothing to punch in, equals 2. So the question that I'm gonna ask myself is, does 2 equal 2? And yeah, 2 does equal 2, so it does check out. So we had 2 possible answers. 1 couldn't fly. We have something to go by, so that's our solution, 9. Sometimes students get nervous and they'll say no solution just because whatever reason, but no, we write no solution when we have nothing to go by. So let's just say that 9 didn't check out either, then we could be like, oh man, there's nothing to go by, so like, yeah, there's no solution. So don't be like very happy with that no solution button. Okay guys, so I said that we were gonna do 2 problems. Let's go ahead and knock out our second and final problem. Okay, so problem number 2. Okay, so we have another radical equation and same speech. How many radicals do I have, 1 or 2? And as you can see, we have 2. So your first goal is to fix it so you have a radical on each side. Both of our radical expressions are positive, so it's really a personal choice which one you want to move. I'm gonna move the second one just because, I don't know, it caught my eye. So if you choose to subtract that second radical term from both sides, radical expression. That will leave us with the square root of 2x plus 5 equals whatever you like on the right side. I just want to make sure that 5 is positive and the radical is negative. Okay, I gave you my piece where I put the radicals at the end. So at this point, we're going to go ahead apply the power rule and raise both sides to some power to undo at least one of the radicals. We focus on the one that's isolated. So to undo the square root, let's go ahead square both sides and then tell the reader what we're left with. So on the left side, the square and the square root undo each other, and that will leave us with the radicand of 2x plus 5 equals whatever you like on the right side. So again, it all how you choose to square it, it's a personal choice. It just depends on how comfortable you feel with these multiplication shortcuts. If you're like, yeah, I remember squaring a binomial, that's going to give us 25 minus 10 square root of x plus 2 plus x plus 2, go for it. But again, if I just pretend that we're having a moment, then we're going to be good. So let's go ahead FOIL it out. So we are going to rewrite the right side without the exponent. So that means that we're going to have 2 factors of the base. Cool. So let's go ahead FOIL it out and then see what that gives us. Product of 5 in itself will give us 25. Product of the outer terms will give us negative 5 times the square root of x plus 2. Product of the inner terms will give us the same thing, minus 5 times the square root of 2, and the product of the last terms will give us positive, whatever you like. It's really up to you how you choose to write the expression. You can write down the simplified product of x plus 2 or write it however you like. So for me, this is how I'm going to do it. X plus 2 times x plus 2. Well, I'm just going to use exponents for repeated factors. So again, this is not the easiest way, but we just don't, or the hardest way. It's just not feasible for me to write 3 different ways to express it. Okay, so let's go ahead, continue to simplify. So we have 25. When we combine the middle terms, negative 5 minus 5 will give us negative 10. And that will leave us with negative 10 times x plus 2. Then we're going to add to it whatever this simplifies to. Well, check it out. You know how the square and the square root undo each other? Well, same speech. The square and the square root are going to undo each other, and that will leave us with the radicand of x plus 2. Fantastic. So let's just go ahead, continue to clean up the right side. So on the right side, we have this x term. I believe we have some constant terms. So 25 plus 2, so that will give us 27. And then we're going to bring down the radical. So minus 10 times the square root of x plus 2. And I think we simplified it as much as possible. So now I'm going to bring down the left side. So now we still have a radical equation, as you can see, but fortunately it's a radical equation now with only one radical. So let's go ahead, work our magic and isolate that one radical that we see. So let's go ahead, subtract x from both sides, and while we're at it, we're going to go ahead, subtract 27 from both sides. Okay, so bear with me, it's going to take me a while. When we choose to subtract those 2 terms, that will leave us with x minus 22 is equal to negative 10 times the square root of x plus 2. So again, when it comes to solving radical equations, if you only have one radical, you're supposed to isolate it, but we're at the same situation as the earlier problem. Technically, I'm supposed to divide both sides by negative 10, but you know what? If we divide by 10, 10 doesn't go into x into 20. 10 does not go into x and into 22, so that will give us a fraction, and we have no time for that. So multiplying a radical by a number is okay, it's fine. So now let's work our magic. To undo the radical, we're going to go ahead, use the power rule and raise both sides to whatever that index is. In this case, it's 2. So let's go ahead, square both sides. Cool. So when we do, the left side should give us x squared minus 44x plus whatever 22 squared is. I'm not going to pretend I can do that in my head. Okay, so let's go ahead, FOIL it out. So that will give us x minus 22 times x minus 22. So pretty much write it without the exponent of 2, or go straight to the simplified product. On the right side, we are squaring more than one of these things, so I'm going to square these one at a time. The square of negative 10 will give us 100, and the square of the square root, the square and the square root undo each other, and that will leave us with x plus 2. So it's 100 times x plus 2. Let's go ahead, wrap it up. Yeah, these numbers are looking pretty spicy. It's okay. We got a calculator, so we can do it. So on the left side, let's go ahead, FOIL it out. Product of the first terms gives us x squared. Product of the outer terms, negative 22x. Product of the inner terms, encore presentation. And product of the last terms, where's my calculator? Because I don't have my notes in front of me, so yeah. 22 times 22 is 484. Fantastic. Okay, so plus 484 is equal to, let's go ahead, clean up the right side. Product of 100 and x will give us 100x. Product of 100 and 2 will give us 200. Okay, that's pretty spicy, but it's okay. I have faith in you. We got this. Okay, so on the left side, let's go ahead, combine the like terms. So the sum of the variable terms will give us negative 44x. We have one constant term, and let's go ahead, bring down the right side, which is already simplified. So we had a radical equation. Now we have a degree 2 equation or quadratic equation. There are different ways to solve it. We can do factoring, but these numbers are out of my comfort zone. So with your permission, we're going to go straight to quadratic formula. So let's do this. To solve an equation by using quadratic formula, let's go ahead, put it in standard form or set it equal to 0, and then we'll take it from there. So let's go ahead, move the 100. So let's go ahead, subtract 100x from both sides. And while we're at it, let's go ahead, move the 200. Usually I only move the terms one at a time, but I'm feeling a little bit adventurous because I have a space to underneath. I have a space to line it up underneath. That's what I was trying to say. So that will give us x squared minus 144x plus 284, how normal people speak. So again, we can solve by factoring. I don't know if it's factorable or not, but this 284 is in my way. So I'm very thankful that we do have, we can solve by using the quadratic formula where you can complete the square. So quadratic formula, once you set the equation equal to 0, let's go ahead, write down the formula. So we have x equals opposite b plus or minus the square root of b squared minus 4ac, and that's all over 2a. The toughest part about solving a quadratic equation by using the quadratic formula is remembering the formula itself. From there, you know, the rest is history, as they say. But we just have to make sure that we put the numbers in the right place. So for that reason, I will always label the values for a, b, and c. So a is always the leading coefficient, b is the coefficient of the middle term or the linear term, and c is that constant term. So if this is our question, this is our answer. Let's plug and check and have your calculator ready. So we have x equals opposite b, value of b is negative 144. And then we're going to add or subtract the square root of b squared. Value of b is still negative 144. Minus 4 times a. Value of a is 1. Times c. Value of c is 284. Okay, so this is a strictly an arithmetic problem at this point. Sorry, all over 2a. But I'm not going to go straight to answer because I don't even know right now if my answer is going to be rational or irrational. It just depends whatever the square root simplifies to. So let's just keep going. So opposite of negative 144 is a positive 144. And then we're going to add or subtract the square root of whatever that radicand simplifies to. Okay. So yeah, I highlighted it right there. So we have square of negative 144. Let me see if you can see that. Okay, I think you can. So we have square of negative 144. That's not a square. Okay, cool. Minus 4 times 1. Yeah, I didn't need the 1, but I put it in there. Okay, so that gives us 19,600. Oh gosh, good thing we have access to a calculator. So we have 19. Was it 19.6? Yeah, I should keep it here, but I don't have a lot of space on my desk. All over 2a. Sorry, all over 2 times 1, which is 2. Let's go ahead and see what the square root of 9,600 is. So square root of 19.6, it gives us 140. Look at that. Okay, so we have x equals 144 plus, what was it again? I need to keep this here. Okay, plus or minus 140 all over 2, and then you are gonna handle it however you can. Okay, so solution number 1 or proposed solution, 144 plus 140 all over 2. Solution number 2, 144 minus 140 all over 2. I'm running out of space, so I'm not gonna do it mentally. Who am I kidding? I'm gonna just punch it in. So we have 144 plus 140 is 284, and you half it, or in this case divide by 2, and our proposed solutions are 142. The other one, 144 minus 140 is 4, and then 4 over 2 is 2. So I should have put it in my calculator because things happen when you're a little bit tired. Okay, so the proposed solutions are 142 and positive 2. We know we nailed it, but again, we were working with a radical equation. So when it comes to radical equations, checking in is not optional. So let's go ahead and check. I'm going to write as high as I can. Cool, so let's go ahead and check our answers one at a time. So I check them in the order that we find them. We're supposed to check it by hand, but again, we were given the green light to use a calculator, so let's go ahead and use a calculator. I can't project the original problem, so you're just going to have to trust me on it. So the original problem reads square root of 2x plus 5. When we add to it square root of x plus 2, by some miracle, it will be nice if it equals 5. And I say it will be nice because we don't know if this is really a solution. So again, if you don't have a graphing calculator, then just plug it in and use a regular calculator. So let's go ahead and store it for x. So we're going to put 142 and then we store it. So again, where is that button? So that the store button is to the left of the digit 1. So we hit store, and then the arrow should pop up, and then you store it however you want to store it. So we're going to store it as x, and then we're going to hit enter. So there, the calculator has stored it. So now we can just write the expression on the left. So expression on the left reads square root of 2x plus 5. Get out of the radical, use your side arrow, plus square root of x plus 2. And then we can hit enter. So the left side simplifies to 29. The right side gives us 5. Last time I checked, 29 and 5 are not equal, so this doesn't check out. So 142 is not a solution. It doesn't mean that the other one has, or doesn't have to be a solution. Let's go ahead and check it as well. Okay, where am I to? Okay, so we want to check 2. Okay, I'm not gonna write the equation again for purposes. Okay, when we check 2, what is that gonna give us? So first we need to store 2 for x. So 2, store it as x. Cool. Okay, it's there. So let's go ahead and write the expression. So I know that some students may be like, Miss Torres, why don't you just do second entry? You know, yeah, I could, but I like students to have practice of punching in the button. So let's clear that. So second square root 2x plus 5. I've said my name, I'm not a secret anymore. Plus the square root of x plus 2. And let's see what that gives us. So this is going to give us a 5 on the left side, equal sign, and we had a 5 on the right side. So the question is, does 5 equal 5? Of course it does. 5 does equal 5. So although 142 is not a solution, looks like 2 is. Okay. Students sometimes just cross out the 142 and circle the 2, but that just looks weird, like if you box it right here. So no, just write it over. Okay, yeah, of course, if I had more space, I will write it below. But when we don't have space, we write wherever we can. Thanks, guys. That's my time.